We have grown up in an era with ever-increasing accessibility to stories, cartoons, and movies, and all of them are becoming more and more tangible. There's no doubt that at some point we have all had our own favorite superhero and wish that we could be more like them. Can you still recall your personal favorite? Mine must have been Wonder Woman. Though another one that comes to mind is Iron Man, a superhero who's wearing a unique, high-tech, weaponized suit of armor to fight evil. Now, so far, superheroes have all been great entertainment, but we all realize it's highly animated fiction, created with the purpose of making us fantasize. However, what if I told you that an Iron Man-like suit is no longer merely a fantasy, but an actual possibility in the near future? As advancements in robotics progress at an ever-increasing rate, more and more robotic devices are popping up around us. Some of these are fully autonomous and mostly put to practice in the industrial world. Often far behind closed doors, as is the case in, for example, the car industry. Yet others are more likely to make an appearance in our daily lives. Think, for example, about robots designed to provide company to the elderly, or autonomic vacuum cleaners. Those are all examples of robots that first of all work autonomously and secondly replace the operator. Despite the many promising applications, this course will not further focus on robotics as such. Because on the other hand, there's another type of robotic devices to be distinguished, called wearable robotics. Those particular devices work in tandem with the operator, usually to augment, reinforce, or even restore human performance. A term that describes this robotic class, and which we will be using throughout the further course, is exoskeleton. In this video, you will learn what exactly this term covers, which different exoskeleton purposes and types exist, and finally, what specific exoskeleton this MOOC will be focused on. Now let's get started and find out about the basics of exoskeleton technology. Hopefully, you will be as excited about the many possibilities as we are. First of all, we will set out by getting a good understanding of the term exoskeleton. The literal meaning of the word refers to a rigid, external, and supporting cover of the body. Think, for example, about the shell of a snail or the scales of a fish. Now, more recently, it has gotten another meaning as well. From a more technological point of view, we will interpret an exoskeleton as a wearable device which contains a framework that goes around the user's body. This framework can either be made from hard materials, such as metal or carbon fiber, or alternatively from soft and elastic materials, such as certain fabrics. Just as the frame can be made from various materials, exoskeletons also have different methods to power them. As such, exoskeletons can be passive, which means that they can only be used to amplify a person's own strength in a mechanical manner. The airframe exoskeleton that can be seen here is a passive one. It was developed to provide mechanical support for workers who engage in repetitive elevation of the arms. Here is a short video from the manufacturer that shortly explains how the suit works and what the advantages are.
The Levitate airframe exoskeleton. Repetitive motion puts significant stress on the shoulder, neck, and back muscles, leading to fatigue and potentially injury. The airframe counterbalances the weight of the arms and tools and safely transfers strain from the shoulder, neck, and back to the outside of the hips, lowering ergonomic risk to a healthy level. The airframe slips easily on and off and moves seamlessly with the wearer, without intruding into the workspace or limiting motion or dexterity. And it's mechanically self-powered, no batteries or cords necessary. Unlike bulky competitors, the airframe is incredibly lightweight, low profile, and breathable. For more specialized types of work, the airframe is safety harness compatible and is available in a fire retardant version. The airframe's modular design can be customized to a wide variety of body types to fit virtually any worker. The Levitate airframe is changing the way manufacturers, warehouses, and construction companies approach worker health and productivity. With some of the world's largest manufacturers deploying thousands of airframes and workers' compensation providers recommending the airframe, it is the undisputed leader in exoskeleton technology.
Isn't it astonishing to know that the needed effort is reported to be reduced by up to 80%? More and more of such mechanical exoskeletons are appearing on the market with various applications. Besides passive devices, such as the airframe, exoskeletons can also be powered, which implies that they are motorized and thus need some type of power supply. There are many possible ways to power such a system, including electric motors, pneumatics, hydraulics, or any combination of these. One of the very first examples of a powered exoskeleton dates back to the 1960s, which was when the company General Electric attempted to create one that would be able to help a person lift more than 680 kilograms. It was called the Hardyman. Unfortunately, it was never actually turned into a working product. It turned out to be very challenging to get all the components to work together and at the same time keep the device weight within acceptable limits. Fortunately, a lot of progress has been made since this attempt. Nowadays, we are looking at a broad range of passive and powered exoskeletons that can be subdivided in yet another 3 groups. Those groups are based on what body parts are actuated or powered by the wearable device. We already saw that the airframe exoskeleton was aimed at increasing upper body strength, whereas the Hardyman had the goal of increasing full body power. Here, we make a distinction between upper extremity, lower extremity, and full body exoskeletons. The first of these type, upper extremity exoskeletons, are used to provide support to the upper body only, thereby augmenting the function of the shoulders, arms, and torso. This particular type is mostly seen in industries and workforces as a means to help heavy lifting work. A recent example is the Ottobock Pexo shoulder that relieves strain on the shoulder joints and upper arms while performing overhead work. Secondly, there are the lower extremity exoskeletons, focusing on the function of the legs, hips, and lower torso. Just like the upper body exoskeletons, these are also used to enhance our physical abilities. However, another important application is gait rehabilitation, which means that those devices can be used to assist patients with mobility. One officially approved exoskeleton that is used for this purpose is called the ReWalk, and it is now used in multiple clinical settings as a rehabilitation system. The ReWalk is also commercially available for personal use and allows people with a spinal cord injury to stand upright, walk, turn, and even climb stairs again. Finally, there are exoskeletons that provide support to the whole body and are thus the most powerful exoskeletons. Those are called full body exoskeletons. Marketed as expanding the limits of human potential, the Guardian Exo from Sarcos Robotics is a great example. It's said to amplify the user's strength with a minimal factor of 20, and it's hard not to imagine that this is the wish of any industrial entrepreneur looking to optimize his or her workforce productivity. Now, I hope you agree, after having seen the examples in this video, that the exoskeleton technology is fascinating. Whenever people hear or read about exoskeletons, they often become intrigued and can't stop themselves from wanting to know more. And one of the most commonly asked questions is, well, how do exoskeletons work? In the latter weeks of this course, we'll go into more depth about the mechanisms behind this technology. Furthermore, the various design processes that should be taken into account will also be covered. However, before getting there, we will first take a closer look at the different exoskeleton purposes and tell you more about the particular exoskeleton that this course is focused on.